Hello everyone and welcome to this lecture called An Introduction to Lithium Batteries. In this session, I will describe the various components of this amazing battery system, how it works, and what materials can make up its most important parts. When we think about batteries, there are many images that come to mind. Perhaps we imagine our car battery or the battery that we sometimes need to charge our TV remote control, or perhaps even the battery that powers our mobile phone. That's one we surely always need to keep charged. Batteries are everywhere, both single-use and rechargeable one. But what is the main difference between these batteries? The main difference between battery types lie in their gravimetric and volumetric energy densities. Essentially, how heavy or light and how large or compact they need to be to perform in a comparable manner. Lithium-ion batteries typically outperform lead-acid ones with significantly higher energy densities. This means that they are lighter and smaller for the same energy output, making them ideal for electric vehicles where weight and space efficiency are crucial for performance and range. But how does such a lithium-ion battery work? A lithium-ion battery is made up of an anode, cathode, separator, electrolyte, and two current collectors. The anode and cathode store lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode and vice versa through the separator. The separator blocks the flow of electrons inside the battery. During battery discharge, the anode releases lithium ions to the cathode, creating a flow of electrons which we use to power our devices. When the device is charging, this process reverses and the cathode releases lithium ions, which the anode absorbs. The lithium-ion battery has gained such significance in our life, powering everything from our mobile phone and laptop, and enabling the rise of electric vehicles. Recognizing the profound impact of this technology in society, its developers were awarded the 2019 Nobel Prize in Chemistry. In the next part of this session, we'll take a look at which cathode and anode materials are actually used in your battery and what the main differences between these materials are. When we talk about electrode materials for batteries, these are often described by two key terms: energy density and power density. Energy density in watt-hours per kilogram shows how much energy an electrode can store for its weight. Power density in watts per kilogram shows how quickly the material can deliver power for its weight. The main cathodes that are currently used in lithium-ion battery, moving on from the lithium cobalt oxide or LCO that was initially used, are lithium cobalt manganese or aluminum oxides, more commonly called the NCM, NCA type cathodes, and lithium iron phosphate or LFP. However, if you look at the graph, you can see that in the development of cathode materials over time, the main gains that have favored their commercialization are not only gains in energy density, but also other performance parameters like cycle life and thermal stability or safety. For example, LFP has a lower energy density than LCO and NCM, but has a better cycle life and thermal stability, which is why it is also highly utilized commercially. As anode or negative electrodes in lithium-ion batteries, graphite is the most highly used material. A lot of other candidate materials are being intensively researched, as shown in the figure. However, among these, the silicon-carbon composite anode, which has a higher density than graphite alone, is one of the more promising. To summarize, I would like to reiterate that the development of lithium batteries has been a game changer, powering everything from phones to electric vehicles. They are lightweight, efficient, and versatile. By learning how they work and what materials go inside them, we see why they're so important. As technology improves, these batteries are getting safer, lasting longer, and storing more energy, helping to make our lives and devices better every day.